The idea of placing an aircraft aboard a submarine for reconnaissance purposes emerged even before World War I. A young British naval officer, Lieutenant Charles Dennistoun Burney, together with the British and Colonial Aeroplane Company, created a special seaplane. 3 prototypes were built under conditions of extraordinary secrecy. These machines were called Bristol Burney Type X seaplanes. One of them had folding wings to make it easier to use on a submarine. In 1916, 2 Sopwith-Schneider seaplanes were placed aboard the British submarine E-22 in an experimental compartment. But it was only in the mid-1920s that other machines appeared, created specifically for basing on submarines. Among them were the German Casper U-1, the American Martin MS-1 and Cox Clemen XS-1, as well as the Italian Machi M53 and Piaggio P-8. Later, during World War II, Germany and Japan built experimental aircraft for submarines, the Arado R-231 and Aichi Seiron respectively. But the most ambitious and probably the most successful attempt to use an aircraft on a submarine was the conversion of the British submarine M2, which was completed in April 1928. On this submarine, the ship's 12-inch gun was replaced with a hangar for a seaplane. The hangar housed a small 2-seat biplane, the Parnall Peto, manufactured in the town of Yate by George Parnall's company. Harold Ballas designed the Peto according to the requirements of the Air Ministry, which wanted to obtain for the Royal Navy a 2-seat reconnaissance aircraft capable of being housed and operating in the confined space of a submarine. Naturally, the wingspan had to be short, and the wings themselves had to be foldable. With such limitations, the designers had to show considerable ingenuity to combine good flight characteristics with adequate seaworthiness. Eventually, the Parnall Peto prototype appeared in 1926 in the form of a compact 2-seat biplane with wings that had a swept shape and unequal span. The central section of the upper wing was positioned at eye level for both crew members to provide maximum visibility without changing the flight path. Only the upper wing had dihedral. The wing frame consisted of spruce spars, ribs, and diagonal struts, held together internally by ties. The wings were connected to each other by streamlined stainless steel struts forming a Warren truss. The central section of the upper wing was supported and attached to the fuselage by means of round cross-section stainless steel struts. The basis of the Peto fuselage frame consisted of spruce longerons connected by spruce and stainless steel struts. Bracing wires were hardly used, except for those placed inside the struts in front of the observer's position. The upper part of the fuselage had a dome-shaped form and was connected to the central section of the upper wing by means of short, streamlined struts. The fuselage behind the forward cockpit had fabric covering, while in front of it, quick-release aluminum panels were installed. A system of levers and cranks located adjacent to the crew cockpits actuated the ailerons, which were positioned along the entire span of the upper wing consoles. The Peto's tail unit had a mixed construction. The frame of the fin and rudder were made of steel tubes. To reduce the height of the storage space, the vertical tail was shifted downward. The fin was placed under the fuselage, and the balanced rudder was attached to the upper and lower longerons of the fuselage. The stabilizer, located at the top of the rear part of the fuselage, had a wooden frame and could be adjusted in flight. All tail surfaces were covered with fabric. The seaplane's landing gear consisted of streamlined N-shaped struts in which the front and rear supports were connected by cables through cross-bracing. 2 Duralumin single-step floats were attached cantilever style to the front and rear supports of the N-shaped struts. The floats had a V-shaped bottom of the long type and were equipped with water rudders. Alternative floats for the Peto were manufactured by the C.E. Saunders Company. These floats were made using the company's well-known Consuta system, in which sections of mahogany plywood were stitched together with copper wire. Early in its career, the Peto was fitted with wheeled landing gear, the enlarged wheels of which were borrowed from the much larger Parnall Pike reconnaissance aircraft. Previously, some confusion arose over the number of Parnall Peto aircraft built. This happened because only 2 aircraft were built from scratch. Later, the first machine was rebuilt and given a new number. To confuse matters even further, both of the first Peto aircraft were fitted with no fewer than 6 wing variants at different stages of their careers. The aim of various wing experiments was to find the best combination of wing design and slat type so that the aircraft would show the best results in all parameters. This was done by trial and error. The main task was to achieve a speed of 110 miles per hour combined with a low landing speed. This is what the Peto was supposed to demonstrate during trials. According to reports, despite its miniature size, the Peto was very maneuverable on water and easily handled against wind and current. In folded form, the aircraft was ideally suited for storage on submarines, precisely the role for which it was created. Initially, the first prototype was fitted with a 135 horsepower 3-cylinder Bristol Lucifer 4 radial engine, but was later replaced with a 135 horsepower Armstrong Siddeley Mongoose engine. The engine was attached to the fuselage by means of a simple beam plate made of stainless steel tubes, and the engine cowling was lightweight and removable. The 14.5-gallon fuel tank was located in the fuselage under the central wing section, and directly below it was a 1.5-gallon oil tank. The use of stainless steel in the Peto's construction was an obvious solution for combating corrosion of metal elements. The Royal Navy and Royal Air Force were well aware of the destructive consequences that could occur when aircraft metal operating over the sea was exposed to the elements. The inclusion of stainless steel in the Peto airframe construction made the machine more expensive, but George Parnall emphasized that the additional costs were offset by reduced aircraft maintenance expenses. The second Peto prototype, which made its first flight at Felixstowe in the summer of 1926, was fitted with a Bristol Lucifer engine with a 2-blade wooden propeller. According to reports, the Lucifer engine developed 127.8 horsepower at 1,700 revolutions per minute. The Peto's characteristics are given in a report by the Marine Aircraft Experimental Establishment presented in July 1926 by Flying Officer Oliver Edward Worsley. The report noted that the aircraft had good handling both on calm water and in the air, although in rough water the machine was difficult to manage. However, this was compensated for by the good flight qualities and ease of maintenance of the Peto. The report further stated that the Peto had a solid construction, was easily brought to a state of readiness, and the float type was quite satisfactory. However, the first prototype failed to achieve the practical ceiling of 11,000 feet specified in the specification. The maximum altitude achieved by the machine was only 9,500 feet. An unusual feature of the Peto was the method of starting the engine. The hand starting device was located not in the pilot's cockpit, but in the front part of the observer's cockpit. As a result, one of the first tasks of the unfortunate observer was to crank the starting handle until the engine started. In early 1930, the first prototype suffered a mishap when in Gibraltar the Peto, operating from submarine M2, made a forced landing on water and was damaged. After the aircraft was pulled from the water of Gibraltar Bay by a harbor crane, it was simply lifted onto the pier by its tail. On the pier, the Peto lay forlornly next to a Ferry 3F seaplane, which had also been knocked down after an unsuccessful landing. However, this accident was not the end for the first Peto prototype, which was returned to George Parnall's factory in Yate, rebuilt, and given a new military serial number. During modification, the aircraft received an Armstrong Siddeley Mongoose 3C radial engine and a Ferry Reed duralumin propeller. As a result, at 2,035 revolutions per minute, the engine could develop 169.2 horsepower. Other improvements included the installation of heavier duralumin floats with a steeper nose section, providing increased buoyancy and significantly improving the aircraft's handling characteristics on water. A special mechanism was installed on the aircraft that could connect or disconnect the water rudders and rudder as needed. The first Peto prototype was also fitted with wings with straight tips and slats, as well as means for launching from a deck catapult. The Admiralty decided that converting the large M-class submarines into aircraft carriers was the Royal Navy's most obvious choice. 4 boats of this class were ordered during World War I, and initially they were planned to be used for shore bombardment. Each boat of this class was armed with a 12-inch gun and modified with the installation of an electrically controlled waterproof muzzle cover and simple sighting devices that allowed fire control from the conning tower. The gun's horizontal traverse angle was small, but its vertical elevation angle was 30 degrees. One method of submarine attack was to move at periscope depth with the muzzle above the surface, fire one shot, submerge, and return to the surface to repeat the procedure so that the time spent on the surface was less than 80 seconds, the time required to reload the gun. This firing system was known as the dipping chicken and proved quite effective in application. The M-series submarines were built by 2 companies, the first 2 by Vickers and the next 2 by Armstrong, However, the last boat was never completed. The first boat was completed on time, launched, and served in the Mediterranean and near the Dardanelles. On November 12, 1925, it sank after a collision near Start Point in Devonshire. The third boat was converted into a very successful mine layer and served until 1932, when it was sent for scrap. The fourth boat was not completed. It was launched in July 1919, only to free up space at the shipyard. In 1921, it was sold for scrap. Thus, it was the second boat that had the honor of becoming the carrier of the Parnall Peto seaplane. In 1927, this huge submarine began to serve as a kind of aircraft carrier. Instead of the 12-inch gun, an aircraft hangar was installed on the boat. The hangar was waterproof and strong. It could withstand the pressure at the depths to which the submarine dove. Externally, the hangar had a rounded shape with a hemispherical top, and the doors measured 9 feet 3 inches by 8 feet 9 inches. Above the hangar stood a lifting crane that could lift the aircraft on board or, if necessary, lower it onto the water for takeoff. Although the aircraft could also be launched from a short catapult installed on the bow of the submarine. This catapult was developed by R. Falkland Carey. It operated using a system of belts, pulleys, and a piston on compressed air or cordite. The catapult could launch aircraft weighing up to 7,000 pounds at a speed of 45 miles per hour with an acceleration of 2.5 g. The length of the catapult boom was 34 feet. To allow the aircraft to operate over the sea for a month, fuel tanks holding 200 gallons of gasoline and oil tanks, with a total capacity of 20 gallons, were placed in the hangar. The submarine's conning tower was raised to make room under the hangar and protect the crew when the aircraft, after landing on water, was lifted by crane back on board. For protection against enemy aircraft, the boat retained a 3-inch anti-aircraft gun installed behind the conning tower. When the aircraft was stored in the hangar, its wings were folded and it stood on a trolley that moved along a short rail. Before launch, the large hangar door was lowered, creating a platform. Rails were quickly laid on it, connecting the catapult rails with the rails inside the hangar. Then the aircraft was quickly rolled off the trolley and secured to the rear of the catapult, after which the wings were deployed and locked. When the pilot started the engine and gained the power required for takeoff, he raised his hand, giving a signal to the submarine captain. The captain signaled the sailor and engineer, and they released the catapult lever. The aircraft shot forward. Within seconds, the machine with 2 pilots, who felt some discomfort during acceleration, was in the air. The first to take to the sky in the aircraft were Lieutenant C. W. Bias and Lieutenant C. Kegley Peach. They received double pay, one for being naval aviators and the other for being submariners. The first prototype aircraft served on the submarine twice, first under one number and after recovery from the accident in Gibraltar under another. In its new form, the aircraft was involved in a disaster on January 26, 1932, when the submarine failed to surface after leaving the base at Portland for a routine dive. Later that day, the Admiralty announced, "This evening, news has been received that a submarine submerged at approximately 10:30 in the Portland area and has not been heard from since. Destroyers and submarines are combing the area of its last known position, and every ship is attempting to establish contact with it." The Admiralty subsequently published a message. An object, probably a submarine, has been found 3 miles west of Portland Bill at a depth of 17 fathoms on a sandy bottom. Divers have been dispatched from Portsmouth. Confirmation that it was indeed the same boat came on February 3rd when it was found at a depth of 108 feet. Unfortunately, 7 officers, 51 sailors and petty officers, and 2 Royal Air Force pilots perished with it. The aircraft was managed to be extracted from the hangar of the sunken ship, although strong currents made this operation very difficult. When the aircraft was transported to Portland Harbor, it turned out that the Peto was in terrible condition. The airframe was smashed and the Ferry Reed propeller was bent. Restoring the aircraft made no sense, so it was sent for scrap. As for the submarine, the Royal Navy attempted to raise the large submarine. But on September 8, 1932, when the boat was raised to a depth of 18 feet, a severe storm began and M2 had to be sunk again. 3 months later, salvage operations were halted and submarine M2 still lies somewhere near Portland. The cause of M2's loss remained a mystery for several years. When Royal Navy divers first descended to the boat, they found the hangar doors, conning tower hatch, and hatch from the pressure hull into the hangar open. Everything was open. This information immediately spawned a number of theories. The hangar doors were accidentally left open. The hangar doors could not withstand the pressure at depth. Someone gave an erroneous order. After the ballast tanks began filling, ventilation valves were inadvertently left open in M2. Damage to the seaplane, transmission failure. The real cause will probably never be known. But one thing can be said for certain. The Royal Navy Command realized that problems with using reconnaissance aircraft on submarines outweighed all the advantages and ceased all further experiments in this field. And what about the second Peto prototype? For some time, it also operated from M2. On Sunday morning, June 29, 1930, this aircraft became a real sensation. A little later, before noon, the aircraft took off from submarine M2 near the town of Ryde and landed at the Royal Navy Training School located at Lyon-Solent. Unfortunately, as the Peto approached Lyon-Solent and flew over the coast of Stokes Bay, the engine stalled right above the beach huts that stood in a row. During the forced landing, the aircraft plowed through half a dozen huts and, turning over, came to a stop. Fortunately, no one was hurt, but one unfortunate vacationer was forced to hastily run out of the hut completely naked. After the Peto was restored, its usefulness as a military aircraft no longer seemed to be taken seriously. The machine was soon sold to Frederick Charles Howard Allen. The converted Peto was later assigned a British civil registration number. At Ford Aerodrome in Sussex during 1934 and 1935, the machine was being prepared to receive a certificate of airworthiness, but for some unknown reason the work was stopped, and the second Peto prototype was sent for storage. The further fate of the aircraft is unknown, and one can only assume that it was finally dismantled. But there is a possibility that someday someone in some old barn will discover a relic of aviation history with faded letters on the fuselage or wing.